Hello and welcome back. A hard indefinite integral from my resources. Today is the 6th of July 2021. I decided to do this particular one. These are integrals that, and you have seen a lot of these patterns, sometimes with integration, sometimes you've seen them as manipulating trigonometric expressions, solving equations. They have certain patterns, and they're some of my favorites actually. So I'm going to actually do this one very, very quickly. And I'm going to manipulate this particular integral, not by just putting integral, because I have to be writing and copying loads of things. You can actually manipulate from the bottom and get to the top and do some kind of cancellation, or it's actually more natural perhaps to start from the top, the numerator of this integrand, and kind of like get into something that it will fit in there. So I'm going to do some auxiliary workings basically with this. So I'm going to say, you know what, let me get an expression of sine to the 8 of x, cos to the 8 of x, and of course we should be all be able to see in there difference of squares. So that is, I'm not writing workings for that, is definitely that. This is a 5-star question, by the way, so we should be able to see this particular quantity, sine to the 4 of x plus cos to the 4 of x, and we can do more. We can break that at any stage, more difference of squares. In fact, we will do that now. So that is a sine squared of x minus the cos squared of x, which is an identity. But the other one is, of course, the famous 1. So we can throw it away. This is from this difference of squares. So it's a 1. And we could actually do more stuff, but I have no more room there. And therefore I will leave it for the time being. So the question is, how do you manipulate sine to the 4 plus cos to the 4? What can you do with something like that? In particular, when we have this bit here, and of course this is a minus, cos squared minus sine squared is the minus the cos of 2x. So somehow we need to change the arguments from this particular one. And you notice there as well, we have this bit here. So this is now how this works. First of all, let's write this as minus cos 2x. So that's this quantity here. This has become a 1, so we can throw it away. But this now, I'm going to put some work so we can see what I'm doing. And also for me not to make a mistake. So this is, in fact, I can write it like this. And then add to that 2 cos squared x sine squared x. Why am I doing this? I'm completing a square with these 3 terms. It's going to be sine squared plus cos squared all squared. And of course, because I added something that I didn't have, it doesn't really matter. Sorry, I wrote the sine first there. It doesn't matter. Okay, so far, this quantity here, open a bracket, sine squared x plus cos squared x all squared. Check that this is in fact all of this quantity. My pen is dying at the moment, so let's use a different color pencil, a lot thicker this one. Square that, and then 2 lots of that. So that's all good. And this I'm going to write it as a half, and I want to put a 4, half times 4, which is your 2. So it's, oh, this is extra thick, this pen. I don't have anything thinner. I ordered something from the internet, but it will take a little while to come. Okay, so far so good. But then again, we have another 1 here. 1 squared, which is just 1. So that's minus the cos of 2x. And what do we have now in this particular expression is 1 minus a half. In this, we can write it as 2 sine x cos x, and this is going to be squared. And this is going to be minus cos 2x, 1 minus a half, and that is the sine squared of 2x. And if we look now what we have achieved so far, this quantity here turned out to be minus the cos of 2x, 1 minus a half sine squared of 2x. This quantity is definitely non-zero, and therefore we can cancel it. Sine squared of 2x. So I'll return basically back to my integral. This was just a trigonometric manipulation, really. Boom, boom. And to get a cos of 2x, we need to differentiate a sine 2x with a minus a half in front of it, plus c. I don't like this minus in there, and I'm kind of like a little bit concerned. I might have made a mistake in this question. Please don't embarrass me. I'm not going to bother to put any comments on the video. The reason I'm saying that is because if I was to end up with an ugly minus there, probably what I would have done in this question, I would have actually swapped the cos to the 8 with the sine to the 8, so I have a nicer answer. So knowing myself and how I normally think, it's unlikely, as I said, to have left it like this, but you never know. I could have been making a mistake with a minus in there, and if there is, the general idea should be correct. And please do not crucify me. I'm signing out, and I'll see you real soon. Bye for now.